we'll go through some of the preferences. And this is more just a real quick overview of preferences. So let's get into that now. We have a web-based application, and we call these preferences. So all of the job preferences that we have, we will set up. We have our pane on the left to show you where you're going to be going for these preferences. We have our basic information. We'll come in and say, okay, we want to set our connection types up. So our beam to beam, beam to spandrel, keep going down the line for column, column flange, embed, so on and so forth. And we have the ability to say, you know, I want to try to do this maybe as a single angle that is bolted. And if that doesn't work, we can start falling back on second, third, and fourth type of preference. I'll leave it as it is for this presentation with shear plate. We would go ahead and submit that. And then we would go into forces. Now, in this case, the forces are in Tekla in the model, so they will supersede. But we also have the ability to fill out a table. So we can go to specific profiles, or we can just blanket those as maybe all W10s have a certain shear value and a minimum row, so on and so forth. Same thing with the UDL factor. We can give you a factor to use. So 0.5 being 50%, and that's for composite beams as well as non-composite beams. Short span members, and then here's another table again for minimum rows if they are required. But like I said before, we'll just come back here. If it says do not connect remaining, that means it's going to be in the model. We have minimum job requirements, some of our minimum maximums in there, you know, so on and so forth. Like I said, this is just kind of a quick overview. So let's jump into the actual model. So what I'm going to show you is, this is a stick model currently, and we're going to get some connections for beam to HSS column or post, whatever you would like to call it. Same thing with HSS vertical bracing to some wide flange columns, as well as some of the beam to column connections. So we'll first come in here. We have a 1, 2, 3 button process. So 1 being export, we'll go ahead and select export. That's going to come up and tell us, okay, what company you work with. You'll go ahead and select that. Same thing with the preferences that we just looked at, what we're going to use, and then your session name, which can be filled out manually every time, or you can set it up to do something along these lines. So we'll go ahead and say submit. Now what this is doing is it's now extracting information out of this model. So for instance, when we come in here, we know that this is a 10 by 10 half-inch vertical brace. We have some tension and compression, some axial loading for this. Okay, same thing with all the others. For this beam at the start location, we know it's a 2468. We're looking for 20 kips here and a little bit of axial. So all of this information gets pulled and extracted out of the model, goes up to our cloud-based system online, and we start crunching through and creating these components as connections within our system. And as soon as they're done, we will get an email just like this. As you saw, we did 34 connections, and we did that, which looks like it was in 4 seconds. So this one was a quick one, sometimes maybe a minute or so. So let's go in. We're going to go to button 2 and now import. So not only are we importing content, we're physically bringing in components. So these are going to come in as an actual Tekla component. You're going to have not only the complexity that comes along with it, but you're also going to have the ability to look at the calculations, because they now live and breathe within these connections. And everything that's in here is 100% modeled. So you're going to see all the welds, all the bolts, the holes. For instance, you're going to see this is a through bolt as a A307 for erection purposes. Nothing more than that. You have your slotted holes, your shop welds versus field welds, so on and so forth. So getting into more of the meat of this connection, you'll see this is the entire component. Let's go ahead and double click on this component, and you will now have a dialog that comes up. And when you have multiple connections in one joint, which we have 1, 2, 3, 4, 5, 6, you'll notice you can toggle through those. So as we open this, this is vertical brace call out 067. So that's what you would see on any connection code map or shop drawing reference. We have, in this case, the filler beam, which is a 2468 going into the column. So this is one of these two connections. And we can keep going through, toggling through the next one, same thing. It's one of those two. But then when we start getting into, let's see, looks like we may have an issue with internet connection on that portion. Not a problem. We'll go to the reports later. But you have all of that information. So if we come back in here and we go right here, this is a link to our full calculation. So this calc is going to give you the main calc, and it breaks it down the right beam to beam. And you can start toggling through again. You have bolt strength, bolt bearing calculation. Everything's laid out in the same manner every time. Beam strength. You have your shear plate calc, so on and so forth, and your weld. Now, when you come in here, you can go ahead and export this to a PDF, and we're going to compile this for you. So we'll go ahead and say, yes, we want to open this. And now you have this VB067. You have this as a 10-page calculation. It defaults to 8.5 by 11. And that's everything you're going to need for this one calculation. So that is more of the overview of how to get a connection in the model. And let's go ahead and go over to the HSS columns over here, because let's try and make these more efficient, more friendlier for the shop, cost effective. So what you see up here, you have an 18 by 35, and you have 5 bolts on either end. And then you come here and you have a 2150. You have 6 bolts. Okay, it's worth 102 kips. And this one, these connections are worth 83.94 kips. So what if we want to reduce the length or even thickness of these shear plates? Reduce the weld length, the volume, but also what we have at Qnect is reducing the quantity of bolts simply by adjusting the vertical spacing. So as everybody is typically used to, you're going to see vertical spacing of 3 inches on center. Okay, so you have your 3-inch vertical on center, but let's go ahead and adjust that. I'm going to come in and I'm going to say button 3, which is our inspect Qnect. We have the ability to adjust some things. I'm going to tell these to be under a different preference that is called HSS Webinar Opt for optimization. So now that I've selected these, I'm now telling those I'm going to run with that job. You'll see these cones turn red, which means we're going to need to re-engineer these locations. And we're going to simply do just that. So we'll select these. We'll go back to our button 1. And we will re-engineer these just by saying submit. So that went up to our cloud-based system. Again, you'll receive an email as soon as it's done. I'm not going to worry about that too much, because what I do want to show you is we have multiple ways of finding this, where we can just say, okay, is this still running? Are we still looking? And no sessions are actually running. So now we know we can just go to button 2 and bring these back down. So you had 5 bolts on top, 6 bolts on bottom here. And now we have 3 on top, as well as 3 on the bottom. So let's look at the vertical spacing of these. So we had 3-inch vertical spacing. Now we have 4.5 here. And we have 5.5 here. Now this can be controlled in quarter, half, or 1-inch increments. We can definitely define or control how we want to do that. In fact, we have certain fabricators that say, I would much rather do 3-inch, 4.5-inch, and 6-inch, nothing more. And we can definitely control that. So you've seen that we can reduce by doing this. Now, this was worth 80-something kips. Now it's worth just under 50. Same here was, I want to say it was 102. right around 50, but we can take it a step further and we can say, you know, let's optimize some joints and say, we want these to be double angles. So they're going to be knife connections. So let's go ahead and force these to be so. And we'll go ahead again, and I'm going to use some quick buttons so I don't have to go back to button 1 and select that. And now you saw that we reduced the quantity of bolts, but now let's go ahead and bring a double angle connection in. And you may see this updating, try after some time. It's probably our internet connection with the webinar itself. All right, so now you can see on the fly, we have gone from a shear plate to a double angle. Of course, it's knife, so you're gonna have your bottom cope. Okay, but yeah, it's worth 78, so it's gone up a little bit more. But what if it doesn't need to be, right? So let's see if we can actually go ahead and achieve a single angle and start getting rid of some of the complexity here and make this joint a little bit easier, more cost effective. All right, bring this back down from our system. And now going from a shear plate to a shear plate with less bolts to a double angle knife connection, now to a single angle, still with those less bolts. In fact, the weld volume or length is probably roughly around 40 to 45% less than a shear plate because of the nature of the double-sided weld at the shear plate. So that's a lot of the HSS style connections and how to go about adjusting those and getting the best or the most bang for your buck. Now, we can also look at this joint here. We have our gusset and we have, you know, a certain amount of bolts. And what if we can actually taper that gusset to be smaller? You'll get less weld and reducing that, as well as maybe get rid of some bolts here. So we'll go ahead and remove this. And let's actually go in here and say, you know, I want to run this, but I want to run it as the optimized project, not the standard. So we'll go ahead and do that. Okay. And again, I don't know if it's going to come back that fast. Not yet. So we will check to see where we are. We are running multiple iterations on joints, so it does take a little bit longer when that happens. So we're 19% complete, still going a little bit, not a problem. While that's going in the background, we can look at this. So you see we have our Erection aids, we have the bolts here. And like I said before, I'll show a little bit of a comparison when we bring the other connection back into the model, where we're going to now try and taper this back, top and bottom, if possible, and reduce as much weld as we can. Let's see where we are with this. Okay, perfect. It's done. Now we should be able to go back in and import everything back into this joint. There we are. So now we've been able to reduce some of that. Looks like we have the same amount of bolts, but not a problem. At least we can reduce some of the shop and potentially field weld at this joint. All right, so when it comes to optimization and being able to do multiple iterations, I want to show you a little bit of the preferences that we did use for the vertical bracing. Won't touch on it too much, just enough to get the point across. So we have our little detail diagram, which points you in the direction of our preferences. We have a minimum gusset, maximum material use. We're going to clip this corner or not. And then minimum, your maximum gusset. right? So we can say, what's our maximum gusset distance, vertical and horizontal in our view? And then what is our minimum clearance to a column or a beam splice? So on and so forth, with just minimums and maximums. And do we want to make this more economical by cutting back the outer vertical? So what I just showed you in that change. So these all determine how we're going to approach our connections. All right, so I think we're probably good to open up with some Q&A here and see what people are thinking. And what when you bring up any questions, I can, you know, if it makes sense, I can show something on the fly in the model. So
Josh, we do have a question that came up about almost 10 minutes ago by Alex asking, what are the limitations to the software? Does it perform HSS beam to HSS column connections, for example?
Sure. So currently, when it comes to a beam, our current form is wide flange beams. So as far as an HSS beam to anything, we do not supply a connection at this point in time, but we always want feedback from people to see, you know, how often do they see it? What type of connection would you be looking for there? Do you have any details that we could look at? And, you know, we can look at that and see in a priority where that would fit in our system to be able to go through and start updating these or creating brand new connections. Good question.
Alex, if you, let me see. Okay. Mark asks, does the software know the difference between tension only braces and tension compression braces?
Yes. So the way that we do this is when you're in the model, you can go ahead and put tension and compression in. So we can go ahead and take this out. Okay. So let's go ahead and do that. So now it is tension only. All right, so right now we're just going to try and get this, no, let's just do all of them. So we'll go in, and these loads should be supplied on the design documents. And when they are, we can go ahead and place those into the model, and that's how we're going to use this. So we'll go ahead and bring these in. Well, sorry, we'll go ahead and export this out to our system and see if we can track where we are. So you can see we're here. Like I said, we iterate through so many different capabilities or possibilities within this joint. The more minimum and maximum items that you have with more capability within a joint, it'll take a little bit longer because of that, because we're going after maximum potential in a connection. So we saw that came back. We'll now submit that and bring this in. And now as this comes in, it's going to come in just, you'll notice it wasn't with the optimized, but it's going to come in just as tension, no compression. So it should answer that question. Next question from you, Christian.
Yeah, I just in a chat to everyone. If y'all have any other questions, please feel free to answer. Alex, if you want a little bit more on your question, let us know. Mark, I think yours got answered there.
Right.
But we can also, you know, follow up with y'all. Everyone, y'all know how to get in touch with us if you need to.
Looks like we had a question about punching shear on an HSS column. So depending on which edition of AISC that you're working with. If you're in the 14th edition and you have some thicker, so say you have grade 572 for grade 50 for your shear plate, and that is for, say, a beam to HSS column connection. And that shear plate, maybe it's 1/2 inch, but maybe the wall thickness on your HSS is only 5/16, and you're going to end up getting some punching shear. Well, one, we will not bring a connection in into the model that does not work. In fact, instead of that, we will bring a red cone in its place. And when you double click on that red cone, you will get an explanation of why that did not work. And in this case, it would tell you punching shear. Now you can go ahead and turn that on and off depending on 14th or 15th edition, with the little minor differences within the way that things are calculated. Any other questions? Can we have more than one erection bolt, or can we do without any erection bolts? The answer there is yes. So on both fronts. So simply come into the preferences, and where it asks, do you want a number of erection bolts? We don't have to, or we can say, yes, we want 2. We want to have 2 of them. We can go ahead and say what diameter we want them to be, depending on the preference of the fabricator, if they have one. Do they want it to be 307, 325, A490? And the type of hole in the gusset, the type of hole in the HSS, and then offset from gusset in for that slot in the HSS. Any other new questions to come out? Doesn't look like we have any new questions coming out, but feel free to always email. You can reach out. You can get my contact information from Christian, and we can always do more of a live or one-off scenario in our own Zoom meeting together, something along those lines. Go ahead and provide the calculations for that. In fact, discussing calculations, let's go ahead and show you a calculation package just so you're aware of what exists in this environment. So we'll go ahead and go to button 3. And what we're going to do is we're going to inspect this. It's going to come in and it's going to inspect the joints and compile, okay, this is all that lives in this model. So we'll go ahead and select everything that we want in a package, and we're going to sync this. So by syncing the model, we are going to basically create a report of just the connections that have come in the model, nothing we've deleted or removed and then added new ones, just of what's physically there. So we'll go ahead and just call this webinar test, and we'll sync everything that was selected. And when we do that, we can now come up to view the reports on this project. Go to the model sync. We'll go ahead and select this. There's that webinar test. Bring this over to our include list for a report, and we will say submittal package. So it's now compile a submittal package together. We have 8 physical connection joints for the beam to column flange, which has shear and axial. And then we also have 4 vertical HSS joints. So what we can now do is we can go to PDF. And what the PDF is going to do, just like before with your calculation, now this PDF is going to compile this report. You'll get the summary of all of this broken out. It'll be in 11 by 17 shown in landscape. There we go. So you get a breakout of all of the connection. You get the capacity, more of a summary of everything here. You go to the next page, and now we have the strengths that these are worth, as well as all the weld information here. And these are true links that will take you back to your web-based portion of this. And like I said before, 11 by 17 landscape. And let's get into the actual calculation or calculations, and they're all compiled here. You'll notice you have page numbers. Obviously, if you want to adjust that on your own, feel free to do so, but this comes out as shown. Let's see, is a reinforcing plate allowed for tab connections? So let's see, reinforcing plate. Can you elaborate on that just so I make sure I understand your exact question? Are you talking about a column web reinforcement? Are you talking about a beam web reinforcement? I would imagine it might be a column web reinforcement.
Mark, if it's okay, I'll give you the microphone. Can you unmute yourself, Mark?
Let's see, where am I?
We can hear you, Mark.
Okay, so when you get into a punching shear situation, the solution usually is to weld a plate onto the face of the HSS column that
Sure.
solves the punching shear problem.
Okay. So currently, that is not something that we have in our connection library. Now, like I said before, we haven't really run into that too often in that scenario. Most of our clients just say, you know what, it's acceptable to just use 15th edition, and pretty much in all the jobs we've done that with, it has worked out. So if you do have a detail of something like that that you would want to discuss with us, and we could potentially get that in front of our design team, we would love to do that. One thing, as you know, as we build a relationship together, one thing you'll always hear from me is constructive criticism is probably my biggest advantage, I would say. The biggest area we're going to grow the fastest is through constructive criticism. You know, bring things up that you see that you think could be better, or hey, you know, I notice it functions this way. Does it also do this? You know, things like that. And if you have any type of examples, those also help expedite that process.
Okay. Well, Josh, we're coming up half past the hour.
Sure.
So we'll be reaching back out to y'all. Thank you for your questions. And if you need anything else, look for the email. Thank you very much.
Thank you for your time.